Now, in this lecture, we find out the length of line segment X. In the drawing, we have a quarter circle. A or B is a quarter circle. Inside this quarter circle, we have a semicircle. OB is a semicircle. And in addition, we know that line segment AO equals to 10 units in its length. And our mission is to find out the length of this line segment AM, that is equal to X. So first of all, we know that AOB is a quarter circle, therefore this angle AOB must be a right angle, it must be equal to 90 degrees. And side AO and side OB must be also equal to each other because both of them are the radii of this quarter circle, therefore they are equal to each other. But we know that AO equals to 10 units, therefore OB must be also equal to 10 units in its length. Here, this line segment OB is equals to 10 units. It is also the radius of this quarter circle. But OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So we know that the diameter of this semicircle OB is equals to 10 units. Therefore the radius of this semicircle must be equal to 10 over 2, that is 5. We define the center of this semicircle here as P. So the radius OP of this semicircle equals to 5 units in its length. PB is also the radius of this semicircle, therefore it is equal to 5 units in its length. We define the point of tendency of tangent AM with this semicircle as Q. We will join points P and Q together by a straight line. Point P is the center of this semicircle, point Q is a point of the semicircle itself, therefore PQ is the radius of this semicircle, therefore it is equal to 5 units. Here we have rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule number 1. We can actually implement rule number 1 in our drawing. Why? Because in our drawing we have the radius PQ of this semicircle that is drawn to point Q. That is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. Whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. We have also rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point P. From the common external point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule number 2, they are equal to each other. That is to say, PA equals to PB. We can actually implement rule number 2 in our drawing. Why? Because in our drawing, if we focus on the common external point A, point A is a common external point in relation to this semicircle. So from the common external point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they must be equal to each other. That is to say, AO equals to AQ. But AO is 10, therefore AQ must be equal to 10 units in its length. in the next step, we'll extend side AM and side OB by straight line until they touch each other. We define the touching point here of the extended side AM and side OB as N. By doing this construction, we created here the right big triangle, triangle AON. In the right big triangle, triangle AON, we define this angle as theta. We'll continue to focus on the right big triangle, triangle AON. In the right big triangle, triangle AON, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, if you focus on the green right triangle QPN, in the green right triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta, according to the same logic. So, in the next step, we'll prove that the right big triangle, triangle AON is similar to the small green right triangle, triangle QPN. So I write it down. We'll prove that the right big triangle, triangle AON is similar to the right green pig and to the right green small triangle, triangle QPN. So why the right big triangle AON is similar to the green triangle, triangle QPN? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle AON in the big right triangle AON. And it is equal to this angle, this is actually angle PQN in the green triangle. Repeat again. Angle AON equals to angle in the big triangle equals to angle PQN in the green triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. Okay. So if we relate to angle theta as it belongs to the big right triangle AON, it will be called angle ANO. And it is equal to itself. If we relate to angle theta as it belongs to the green triangle, it will be called angle QNP. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. So angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle OAN in the big triangle. OAN. and it is equal to this angle, that is actually angle QPN, the small triangle. Repeat again. Angle OAN equals to angle QPN. So angle OAN in the big triangle, OAN equals to angle QPN in the small green triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles of the big right triangle AON are correspondingly equal to all the three angles of the small green triangle QPN. Therefore we actually proved that the big triangle AON is similar to the small triangle QPN according to angle similarity rule. So I write it down. We actually proved that the big triangle AON is similar, this is the sign of similar, to the small green triangle QPN according to angle similarity rule. And from the fact that the big triangle AON is similar to the small triangle QPN, we derived that the following relationship exists between their sides. We will derive that side AO in the big triangle AON over side QP in the small green triangle QPN equals to side AN in the big right triangle AON over side PN in the small green triangle PQN. Repeat again. We derive that AO over QP equals to AN over PN, and also that it is equals to side ON in the big triangle AON over side QN in the small green triangle QPN. And again we derive that AO over QP equals to AN over PN equals to ON over QN. Okay. AO is 10 over QP is 5, and it is equal to AN. AN, from the drawings, it is very easy to see that AN in total equals to AQ plus QM. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN. AN equals to 10 plus QN over PN. PN in total equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. PN equals to 5 plus BN, and it is equal to ON. What is the length of ON? For the drawing, it is very easy to see that ON in total equals to OP plus PB plus BN. That is to say, ON equals to OP, that is 5, plus PB, that is also 5. 5 plus 5 is 10, plus BN. So in total, ON equals to 10 plus BN. Okay, ON equals to 10 plus BN. Over QN. QN is the missing side, so we leave it as it is. So 10 over 5 is 2. 2 equals to 10 plus QN over 5 plus BN. and it is equals to 10 plus Bn over Qn. Those two sides are equal to each other, so we create the equation number 1 from those two sides that are equal to each other. So according to equation number 1, we get that 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other, so we create equation number 2 from those two sides that are equal to each other. According to equation number 2, we get that 2 equals to 10 plus Bn over Qn. So we have here those two equations. In the next step, we multiply this equation number 1 by 5 plus Bn. And we get that according to equation number 1, two times 5 plus Bn equals to 10 plus Qn. Here we'll open the brackets of this equation. We'll open the brackets of this side of equation number 1, and we get that according to equation number 1, 2 times 5 is 10, plus 2 times Bn is 2Bn, that is equals to 10 plus Qn. Here we have 10 on both sides of the equation, so 10 we get cancelled, and we left only with Qn that is equal to 2 times Bn. This is according to equation number 1. While according to equation number 2, we found out that 2 equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn. And you get that according to this equation number 2, 2 times Qn equals to 10 plus Bn. While according to equation number 1, Qn equals to 2 times Bn. Therefore we can substitute Qn in this equation number 2 by 2 times Bn. We do it now and we get that according to equation number 2, 2 times Qn, and Qn is 2 times Bn. This is equals to 10 plus Bn. 2 times 2Bn is 4Bn. So according to equation number 2, 4Bn equals to 10 plus Bn. Here we substitute, we subtract from this equation number 2 Bn. And we get that according to this equation number 2, Bn, 4Bn plus Bn is 3Bn. This equals to 10. Here we divide this equation number 2 by 3, and finally we get that Bn equals to 10 over 3. Bn equals to 10 over 3. So write down in the original drawing that this line segment Bn equals to 10 over 3 units in its length. Here Bn equals to 10 over 3 units in its length. Bn equals to 10 over 3. According to equation number 2. While according to equation number 1, we have already found out that Qn equals to 2 times Bn. Repeat again. According to equation number 1, we have already found out that Qn equals to 2 times Bn. So, according to equation number 1, Qn equals to 2 times Bn. 2 times Bn, and Bn is 10 over 3. So Qn equals to 2 times 10 is 20, so this expression in total equals to 20 over 3. If we're going to find out that Qn equals to 20 over 3 units in its length. So we can write down in the original drawing that Qn equals to 20 over 3 units in its length. This line segment Qn equals to 20 over 3 units in its length. In the next step, we will complete this quarter circle to a circle. So completed the quarter circle to a circle, and we'll extend line segment BO by sideline until it touches the circle. We define the touching point of the extended line segment BO with this circle as C. Point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of this circle. The radius of the circle and the radius of the quarter circle are same, because we just extended the quarter circle to a circle, so they have the same radius. And the radius of the quarter circle AO equals to 10, therefore the radius of the circle CO must be also equal to 10 units in its length. So CO equals to 10. In the next step, I will present to you rule number 14, and we will implement rule number 14 in our drawing. According to rule number 14, rule number 14 is true in any circle. So in any circle, if we draw two chords A, B, and C, D in the circle from the common external point, point P, then the following equation will be true, that PA times PB equals to PC times PD. So in the drawing, we have a circle, and here we have the common external point, point P. From the common external point, point P, we drew two chords inside the circle, chord AB and chord CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, we have the common external point, point N. From the common external point, point N, we have two chords that are drawn inside this circle. We have chord MA, this is called MA, And we have also, from the same common extent point N, the second code that is called BC. So all the requirements of rule number 14 are met, and therefore we can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. So I write it down. We focus on the common extent point N. According to rule number 14, we get that NB times NC equals to NM times MA. Repeat again. According to rule number 14, if you focus on the common extent point N, NB times NC equals to NM times NA. So first of all, we have to find out the length of this line segment MN. So from the drawing, it is very easy to see that NM equals to QN minus QM. Again, NM equals to QN minus QM. Repeat again. NM equals to Qn minus Qn. So NM equals to Qn. Qn is 20 over 3 minus Qm. So in total, Nm equals to 20 over 3 minus Qm. So we can write down in the original drawing that this line segment Mn equals to 20 over 3 minus Qm. Okay. Now we will return to rule number 14. According to rule number 14, we found out that NB times NC equals to NM times NA. NB is 10 over 3 times NC. NC or Cn, it is the same. Cn in total equals to CO plus OP plus Pn. Again, Cn in total equals to CO plus OP plus Cn in total equals to CO plus OP plus PB plus Bn. So Cn equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5. So in total 10 plus 5 is 20, plus Bn, that is 10 over 3. So in total Cn equals to 20 plus 10 over 3. Here, Cn or Nc equals to 20 plus 10 over 3. And it is equals to Nm. Nm is 20 over 3 minus Qm. 20 over 3 minus Qm times Na. What is the length of Na? Na or An in total equals to Aq plus Qn. That is to say An equals to Aq, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. An or Na equals to 10 plus 20 over 3. So in conclusion, found out that 10 over 3 times 20 plus 10 over 3. We multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator we have 70 divided by 3. This expression in total equals to 70 over 3 and it is equals to 20 over 3 minus qm. Here we multiply minus qm by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So in the numerator of this expression in total we will have 20 and minus qm times 3 is minus 3 qm. So in total in the numerator we have 20 minus 3 qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator of this expression we have 50 divided by 3. So in this equation, on both sides of this equation, in the denominator of both sides of this equation, we have 3 times 3, that is 9. Therefore, we will multiply this equation by 9 in order to eliminate the denominator. And we get that after we cancel the denominator that is 9, we left in this side of the equation only with 10 times 70. That is equals to, on the other side of the equation, we have 20 minus 3 qm times 50. So, in conclusion, found out actually that ten times 70 equals to 20 minus 3 qm times 50. Here we divide this equation by 10 and we get that 10 over 10 is 1, so in this side of the equation we left only with 70. That is equals to, on the other side of the equation we have 20 minus 3 qm times 50, and 50 over 10 is 5. So in conclusion, we found out that 70 equals to 20 minus 3 qm times 5. Here we'll open the brackets on this side of this equation, and we get that 70 equals to 20 times 5 is 100, minus 3 qm times 5 is minus 15 qm. So 70 equals to 100 minus 15 qm. Here we subtract 70 from this equation and we get that 70 minus 70 is 0. That's equals to 100 minus 70 is 30 minus 15 qm. So 30 minus 15 qm equals to 0. Here we add to this equation 15 qm and we get that 15 qm equals to 30. Here we divide this equation by 15 and finally we get that qm equals to 30 over 15, that is 2. So qm equals to 2 units in its length. You can write down in the original drawing that this 9 segment qm equals to 2 units in its length. Our mission is to find out the length of line segment AM. This line segment AM is equal to x according to what is given as a question. So we have to find out the length of line segment AM. that is equal to x. From the drawing itself, it is very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. So I write it down. AM equals to AQ plus QM. So it is equals to AQ. AQ is 10 plus QM. QM is 2. QM is 2. So in total, AM equals to 10 plus 2, that is 12. We actually found out that X is equal to AM, according to what is given in the equation, it is equal to 12 units in its length. And that is the answer to the question. Repeat again, the length of this line segment AM is equal to X, according to what is given in the question, is equals to 12 units in its length. So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM, that is equal to X, according to what is given in the question. So in the drawing we have a quarter circle, AOB is a quarter circle. Inside this quarter circle we have this semicircle. In addition, you know that side or line segment AO equals to 10 units in inside. Again, our mission is to find out the length of this line segment AM that is equal to X according to what is given in the question. Okay. So first of all, AOB is a quarter circle, therefore this angle AOB equals to 90 degrees. And in addition, side AO must be equal to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10, therefore OB must be also equal to 10 units in its length. OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So we know that the diameter OB of this semicircle equals to 10 units. Therefore, the radius of this semicircle must be equal to 10 over 2, that is 5. We define the point of tendency. So here, the center, we define the center of this circle, of this semicircle as P. So PO is the radius of this semicircle, that is 5, and PB is also the radius of this semicircle, that is 5. Then we define the point of tendency of tangent AM with this semicircle as Q, and we join point Q and P together by a straight line. Point P is the center of the circle, point Q is the point of the circle itself, of the semicircle itself. Therefore, PQ is the radius of this semicircle, that is equal to 5. Okay, then we extended side AM and side OB by a straight line until they touch each other. They touch each other here. We define the touching point of the extended side OB and side AM as N. By doing this construction, we created here the right triangle, the right big triangle, triangle AON. Inside the big right triangle AON, this angle equals to 90 degrees. We define this angle ANO as theta. So this angle equals to theta according to our definition. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus 90 degrees. 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the green right triangle PQN. On the green right triangle PQN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta according to the same logic. Okay. Then we proved that the right big triangle AON is similar to the small green triangle PQN. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle that belongs to both triangles. So angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the angles of the right big triangle AON are correspondingly equal to all the angles of the small green triangle QPN. Therefore, we actually prove that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AO in the big triangle over QP in the small triangle equals to AN in the big triangle over PN in the small triangle, and it is also equals to ON in the big triangle over QN in the small green triangle. AO is 10, QP is 5, AN. What is the length of AN? From the drawing it is very easy to see that AN in total equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN. Here, AN equals to 10 plus QN over PN. What is the length of PN? From the drawing itself, it is very easy to see that PN in total equals to PB plus BN. That is to say, PN equals to PB, that is 5, plus BN. So in total, PN equals to 5 plus BN. Here, PN equals to 5 plus BN. And it is also equals to ON. What is the length of ON? ON in total equals to OP plus PB plus BN. So ON in total equals to OP, that is 5, plus PB, that is also 5. 5 plus 5 is 10, plus BN. So in total ON equals to 10 plus BN. It again. ON in total equals to 10 plus BN over QN. QN is the missing side, so we leave it as it is. Okay. So in conclusion, we found out that 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. Here, those two sides are equal to each other, so we created equation number 1 from those two sides that are equal to each other. So according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. And again, according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. Those two sides are also equal to each other, therefore we get the equation number 2 from those two sides that are equal to each other. So according to equation number 2, we found out actually that 2 equals to 10 plus Bn over Qn. Repeat again, according to equation number 2, 2 equals to 10 plus Bn over Qn. So we have here two equations. Here we multiply this equation number 1 by 5 plus Bn. And found out that according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Here we open the brackets on this side of this equation number 1, and found out that according to equation number 1, 2 times 5 is 10, plus 2 times Bn is 2Bn. So 10 plus 2 times Bn equals to 10 plus Qn. Here we have 10 on both sides of the equation, so 10 will get cancelled, and we left only with Qn, that is equals to 2 times Bn according to equation number 1. But according to equation number 2, here we have, according to equation number 2, 2 equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn, and we found out that 2 times Qn equals to 10 plus Bn. This is according to equation number 2. But according to equation number 1, we found out that Qn equals to 2 times Bn. So we can substitute Qn in this equation number 2 by 2 times Bn from equation number 1. We did it and found out that 2 times Qn and Qn is 2 times Bn is equals to 10 plus Bn. So 2 times 2Bn is 4Bn, that is equal to 10 plus Bn. 4Bn equals to 10 plus Bn according to this equation number 2. We subtracted Bn from this equation number 2 and found out that 4Bn minus Bn is 3Bn, that is equals to 10. Here we divided this equation number 2 by 3 and finally found out that Bn equals to 10 over 3. Here this line segment Bn equals to 10 over 3 units in its length. And so Bn equals to 10 over 3 units in its length. This is according to equation number 2. I repeat again, according to equation number 2, Bn equals to 10 over 3 units in itself. Well, according to equation number 1, we have already found out that Qn equals to 2 times Bn. That is to say, Qn equals to 2 times Bn. And Bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So in conclusion, we found out that Qn equals to 20 over 3 units in itself. Here this line segment Qn equals to 20 over 3 units in itself. Then we completed this quarter circle to a circle, and we extended side BO by a straight line until it touches the circle. We define the touching point of the extended side BO, and this circle is C. Point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of the circle. The radius of the circle and the radius of the quarter circle are the same because we completed the quarter circle to a circle, and the radius of the quarter circle is 10, therefore the radius of the circle CO must be also equal to 10. Then I presented to you rule number 14, and we implemented rule number 14 in our drawing. According to rule number 14 is true in any circle. In any circle, if we draw two chords A, B, and C, D in the circle, from the common extreme point P, then the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So in the drawing we have a circle, and we have the common extreme point P. From the common extreme point P, we draw two chords towards inside this circle, chord AB and chord CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, we have the common extreme point N. From the common extreme point N, we have two chords inside this circle. We have chord MA and chord BC. So all the requirements of rule number 14 are met, and therefore we can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again. If we focus on the common extreme point N, according to rule number 14, we get that NB times NC equals to NM times NA. We found out the length of this line 7 MN. From the drawing, it is very easy to see that the length of line segment NM equals to QN minus QM. Again, NM equals to QN minus QM. Repeat again. NM or NM equals to QN minus QM. QN is 20 over 3 minus QM. So in total, MN equals to 20 over 3 minus QM. Then we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. So we have NB. NB is 10 over 3 times NC. What is the length of NC? Or CN is the same. CN in total equals to CO plus OP plus PB plus BN. That is to say, CN in total equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5. 10 plus 5 is 20, plus Bn, that is 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Here, Cn or Nc equals to 20 plus 10 over 3, and it is also equals to Mn. We just right now found that Mn equals to 20 over 3 minus Qm times Na. What is the length of Na? From the drawing, it is very easy to see that Na or An in total equals to Aq plus Qn. That is to say, An equals to Aq, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. Repeat again, here, An equals to 10 plus 20 over 3. So here we actually found out that 10 over 3 times 20 plus 10 over 3. Here we multiplied the 20 by 3 and then we divided by 3 in order to overcome factor with 10 over 3. So 20 times 3 is 60, and 60 plus 10 is 70. So in total, the numerator out of this expression, we have 70 divided by 3, and it is equals to 20 over 3 minus Qm. Here we multiplied minus Qm by 3, and then we divided by 3 in order to overcome factor with 20 over 3. So in total, the numerator of this expression, we have 20, and minus qm times 3 is minus 3 qm. So in total, in the numerator of this expression, we have 20 minus 3 qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor of 20 over 3. 10 times 3 is 30, 30 plus 20 is 50, so in total, in the numerator of this expression, we have 50 divided by 3. So on both sides of this equation, we have in the denominator 3 times 3, that is 9. Therefore, we multiply this equation by 9 in order to eliminate the denominator, that is 9. And we left only with, after we multiplied the equation by 9, we left only with 10 times 70, that is equal to 20 minus 3 qm times 50. Here we divided this equation by 10 and found out that here 10 over 10 is 1, so here we left only with 70. That is equals to 20 minus 3 qm times 50, and 50 over 10 is 5. So in total, we actually found out that 70 equals to 20 minus 3 qm times 5. Here we open the brackets of this side of the equation and we found out actually that 70 equals to 20 times 5, that is 100, minus 3 qm times 5 is minus 15 qm. So in total, we found out actually that 70 equals to 100 minus 15 qm. Here we subtracted 70 from this equation and finally found out that 70 minus 70 is 0. That is equals to 100 minus 70 is 30 minus 15 qm. So in finally found out that 0 equals to 30 minus 15 qm. Here we added 15 qm to this equation and finally found out that 15 qm equals to 30. Here we divided this equation by 15 and finally found out that qm equals to 30 over 15, that is 2. So qm equals to 2 units in its length. This line segment qm equals to 2 units in its length. Our mission is to find out the length of this line segment AM, that is equal to x. Repeat again, we have to find out the length of line segment AM, that is equal to x. From the drawings, it's very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AM equals to AQ plus QM. AQ is 10 and QM is 2. Again, AQ is 10 and QM is 2. So in total, AM equals to 10 plus 2, that is 12. So the answer to this question is that x, that is equal to AM, equals to 12 units in its length. I'll repeat again. The length of line segment AM, that is equal to x, is equals to 12 units. Okay? Thank you very much.